Greetings, young physics learner. This is Mr. Chai. The objective of this video is to teach you about acceleration. Let's start by talking about what acceleration is. Acceleration is the rate of change in velocity. If you look at the bicycle on the right, he is gaining speed, which means he is accelerating. We defined velocity in the previous video as speed with direction, so that means there are several different ways an object can accelerate. Any of these count as acceleration. An object speeding up is gaining velocity, so that would be a positive acceleration. An object that is slowing down is losing velocity or speed, so we would call that a negative acceleration. But keep in mind that does still count as acceleration. Since velocity is speed with direction, an object can go at a constant speed but change direction. That actually does count as accelerating. In an equation, we would have acceleration equals final velocity minus beginning velocity divided by time. Now if we look at this equation, on top we have final speed or final velocity minus initial velocity. Now remember, initials, that simply means the beginning, like the initials are the beginning of your name. So VI stands for initial velocity or beginning velocity. And we divide that by the amount of time it takes. Again, on top we have the change in velocity divided by, on bottom, how much time it took to change the velocity. Let's talk about units of acceleration. Units of acceleration will always be a unit of speed per unit of time. And that's because in that equation we just had, on top we have how much the speed changed, there's our unit of speed, divided by how much time it took. That's on the bottom. If we look at some examples, we have meters per second per second. Sometimes you might see that written as meters per second squared. And that looks confusing, but all that means is we have right here at the beginning meters per second, which we learned in the previous video is a unit of speed. And that is per unit of time. Right here we have seconds, which we also learned in the previous video, seconds measure time. Another example of acceleration might be miles per hour per second. The first part is miles per hour. We learned that that is a unit of speed divided by or per a unit of time, once again seconds. Usually the last one is seconds because things usually accelerate in a matter of seconds. Another example might be kilometers per hour per second. Once again, kilometers per hour is a unit of speed per seconds, which is unit of time. So each of these is a unit of speed per unit of time. What exactly does acceleration mean? Let's take a look at an example. For the bicycle shown on the right, notice that each second it gains 2 kilometers per hour of speed. This bike has an acceleration of 2 kilometers per hour per second. Like we talked about earlier, there are two parts. First, how much did the speed change? Let's look at the speed column, and it's going up, we can see, by 2 kilometers per hour for each row. So that's where that 2 kilometers per hour comes from at the beginning of our acceleration of 2 kilometers per hour per second. The first part, 2 kilometers per hour, is how much did the speed change. The next part is how much time it took to change. Each 1 second that passed, we can look at the time column now. Each row is gaining 1 second, and so each 1 second, the bike gains 2 kilometers per hour of speed. So its acceleration is 2 kilometers per hour per second. Go ahead and pause the video right now and try to answer the question. We have a new example. Try to find out what is the acceleration of the new bike on the left. Once again, we have two parts. Let's look at how much did the speed change, and then we look at how much time it took. The left column tells us time, and it's going by in 1 second increments. And we can see that every 1 second it is gaining 1 kilometer per hour. So this bike has an acceleration of 1 kilometer per hour per second. The first part, 1 kilometer per hour, is how much his speed changed. And the second part is how much time it took. It took 1 second to change his speed by 1 kilometer per hour. Once again, the acceleration of this bike is 1 kilometer per hour per second. Let's practice calculating acceleration. Here's an example. What is the acceleration of a car that accelerates from 0 miles per hour to 60 miles per hour in 4.2 seconds? Let's start by finding the given information in this problem. It says it's starting at a speed of 0 miles per hour and it ends at a speed of 60 miles per hour. and it takes 4.2 seconds to get up to speed. We call this the 0 to 60 test. It's a pretty common test with sports cars. Let's write down the given information. It says the initial velocity, or the beginning velocity, is 0 miles per hour. That's where it starts. And then it's going to gain speed until it's at a speed of 60 miles per hour. And the problem tells us that it took 4.2 seconds to get up to speed. It says, what is the acceleration? So I'm looking for acceleration, which means for my equation, I'm going to use the equation that we learned on a previous slide. Acceleration is final speed minus beginning speed divided by time. Let's plug in the information. Acceleration equals, notice we're starting with final velocity. Our equation says final velocity minus initial velocity, so I have to start with the final. 60 miles per hour is my final velocity, minus 0 miles per hour is my initial velocity, divided by the time is 4.2 seconds. Since everything on top is in parentheses, I have to do that first. 60 minus 0 is conveniently 60 miles per hour. And so I'm going to take 60 divided by 4.2. I'm going to come up with an acceleration of 14.2. The unit is going to be miles per hour on top divided by seconds. So my final answer is 14.2 miles per hour per second. In this example, we're going to calculate the final velocity of an object. The example reads, a hammer is dropped off of a building and it accelerates at a rate of 9.8 meters per second per second. If it starts at rest and falls for 1.2 seconds, what is the speed the instant that it hits the ground? Let's look at the given information. It has an acceleration of 9.8 meters per second per second. Remember, that means each second that it falls for, it will gain 9.8 meters per second of speed. This is an interesting one. It says it starts at rest, and that's sort of a hidden piece of information. If it starts at rest, that means its initial velocity is 0 meters per second, and it says that it takes 1.2 seconds for it to fall. Our given information is the acceleration is 9.8 meters per second per second. The initial velocity is 0 because it says it starts at rest, and the amount of time it takes is 1.2 seconds. The question is asking, what is the speed the instant it hits the ground? And that's the speed after it's done falling, right before it hits the ground. So we're trying to calculate the final velocity. We're going to use the same acceleration equation. Acceleration is final velocity minus initial velocity divided by time. Let's plug in our information. This time we know the acceleration on the left is 9.8 meters per second equals, our final velocity is an unknown, so I will leave that as variable, minus 0 meters per second is the initial velocity, divided by the amount of time it takes is 1.2 seconds. Since I don't like having a fraction in my algebra problem, I'm going to start by getting rid of the 1.2 seconds. Since I'm dividing by 1.2 seconds, I'm going to multiply by 1.2 seconds. Since I multiplied on the right side by 1.2 seconds, I need to multiply on the left side by 1.2 seconds. Now let's simplify. On the left side of the equation, we're going to have 1.2 times 9.8 is 11.6. And on the right side, since I divided by 1.2 and then multiplied by 1.2, those cancel out. I'm left with VF minus 0. I think a lot of us have already realized that the answer is going to be 11.6. But if that number wasn't 0, I would have to still do some algebra. The algebraic step I would take, since I'm subtracting 0, is simply to add 0. Adding 0 on both sides and simplifying, we're just going to be left with final velocity is equal to 11.6 meters per second. Let's do one more example. This time let's calculate time. How long will it take a bike to get up to a speed of 20 miles per hour if it starts at a speed of 2 miles per hour and accelerates at a rate of 2 miles per hour per second? Remember, that means it gains 2 miles per hour of speed for every second that it goes. Our given information is it's trying to get up to a speed of 20 miles per hour. That's at the end of its period of acceleration, so that's its final velocity. It's going to begin at a speed of 2 miles per hour, and its acceleration is 2 miles per hour per second. So our given information is right there. It asks how long will it take, and so this time we're trying to calculate time. We're going to use the same acceleration equation. Acceleration is final velocity minus initial velocity divided by time. So let's plug in that information. On the left side, we have the acceleration of 2 miles per hour per second. And on the right side, final velocity is 20 miles per hour minus the beginning velocity of 2 miles per hour divided by time. I'm going to put a bar there to separate that from the next line. Let's simplify this. We can do the parentheses first. 20 miles per hour minus 2 miles per hour is 18, so this simplifies to 2 miles per hour per second equals 18 miles per hour divided by time. And once again, I don't like having a fraction, so I'm going to try to get rid of the t. Since I'm dividing by t, I should multiply by t. And since I multiply the right side by t, I need to multiply the left side by t. Let's simplify this one more time. On the left side, we have 2 miles per hour per second times t equals 18 miles per hour. And that's because since we divided by t and then multiplied by t, those canceled out. Now I need to get rid of the 2 miles per hour per second so that t is all by itself. Since I'm multiplying by 2, I'm going to divide by 2, which means I need to do that on both sides. Let's simplify one last time. On the left side, 2 times t divided by 2, those cancel and we're left with t equals 18 divided by 2 is 9. The only unit that I can pick for time is seconds. You should check your answer. Is it logical that it takes 9 seconds to get from 2 miles per hour up to 20 miles per hour if it's gaining 2 miles per hour each second? I think so. Hope you learned something about acceleration. If you have any questions, please don't hesitate to email me or see me in class. Hope you have a great one.